Okay, so we need to determine whether these two triangles are similar. So first we need to recognize which two triangles we have. So notice that we have one big triangle here, and we have one little triangle here. So I think it is kind of easier for me to rewrite those two triangles so I can see exactly which goes together, which side goes with which side. So first I'm going to draw the big triangle. It looks something like that. And then I'm going to draw the little triangle. It looks something like that. And now I'm going to label the parts. So that's an 8, that's a 9, that's a 10. And over here on the big triangle, I have a 9 and an 18. So the 9 and the 18 I'm going to add together. So the total of that side is going to be 27. And this length is 18, and this whole length here I'm going to do 10 plus 20, which is going to give me 30. So now I'm going to find my partners. So I've got 27 here, and 27 matches up with 9, so I can say 27 over 9. And I have this 18 that matches with this 8. And then I have a 10 and a 30. So notice I put all of the big triangles measurements on top and the measurements of the side lengths of the small triangle on the bottom. So now I need to reduce these and make sure that each of them are equal to each other. So I can go to my, so I can reduce 27 divided by 9, and I know that that's 3. And then 18 divided by 8 is 2.25, so that right there tells me that's probably not going to be similar. And then 30 divided by 10 is 3, but because all three of them do not have the same reduced answer, this 2.25, therefore I can't say that it is similar because I don't have side, side, side. I only have side, side. And I'm not given any angles, so therefore I can say that this one is not similar. Okay, so if we're given angle measures, then we need to determine if they have the same angle measures, and then we can say that they are congruent by angle, 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 A. So first, we need to determine the missing angle right here. So we know that there are 180 degrees in a triangle, and I'm going to subtract 54, so I'm going to do 180 minus 54 and minus 47, and I know that this angle measure has to be 79 in order for it to add up to 180. So I see now that I have a matching 54 here, and I don't have a 54 over here, but that doesn't mean that it's my missing angle here. I do have a 47 and a 47, and I can already tell I might have a problem because that's a 79 and that's a 78, but let's go ahead and double check. So let's do this triangle. So we're going to do 180 minus 47 minus 78, which would make this missing angle 55, and therefore I don't have three of the same angles, therefore this one is going to be not similar. Okay, so number 21, we need to remember what we know about vertical angles, and we know that the things that look like bow ties, they always have vertical angles here. So what that means is that we have the same angle measure here than we have here. So we have an opportunity. This might be a side angle side because we're given a side, an angle, and a side, but we need to make sure that the two side lengths are proportional. So notice that this is the top of the triangle, so this would be the left part of the triangle. So here, if this is the top of the triangle, this is going to be the left part of the triangle. So make sure that you're matching up your congruent or your similar parts. So we can say 8 over 16 is equal to, and then now we're going to do the right sides of the triangle, 9 over 18. And now let's reduce these to make sure that they are similar. So we can do 8 divided by 16, which is 1/2. We're going to see if it's equal to the same ratio. So we have 9 divided by 18, and that's also 1/2. So what that means is that we have a side that are similar to this side, we have another side that's similar to this side, and we have similar angles. So therefore we can say that this triangle, yes, is similar due to side, angle, side. Okay, we need to determine in number 22 whether the triangle is similar or not. And notice that it only gave us angle measures. So, looking at our choices of whether they are congruent or not, we have SAS that we can rule out because it didn't give us any side lengths, it only gave us angle measures. And same for SSS. It can't be SSS because we weren't given any side lengths. So what we're trying to determine is if this is similar by AA. Angle, angle. Because if two angles are congruent, that means automatically the third one is also going to be the same. So we need to determine, we know, looking at this triangle, we know that this box means that this is 90 degrees. So we need to figure out what this missing angle is by doing 180 minus 90 minus 37. So we know this missing angle is 53. And looking over at our other triangle, we don't even have to determine what this angle is because we do have two of the same angles. We have a 90-degree angle here, 90-degree angle here, and a 53 here, and a 53 here. So we can say this one is, yes, it is similar by angle, angle. And looking at number 23, notice that we have two separate triangles. So we have one big triangle in red here, and then we have one small triangle in blue here. So let's rewrite those triangles to get the correct measurements. Let's do the big one first. So we have one big triangle. So the whole left side here is going to be 15 plus 5. So it's going to be 20 on the left side. And then the whole right-hand side is going to be 6 plus 18, which is 24. So this side is 24, and the bottom is 12. So let's take a look at the little triangle now. And it has, that side is 5, that side is 6, and the bottom is 3. So let's make a proportion for each of these and their matching parts to make sure that they're all equal. So 20 matches up with 5, so we can say 20 over 5 should be equal to 24 over 6, and it should also be congruent to 12 over 3. Notice I put all of the large triangles over the small triangles. And now we're going to divide each of these to make sure that each of the proportions are the same. So I know that 20 divided by 5 is 4. It should equal this. So 24 divided by 6 is also 4. And we can't stop there because we need to make sure that all three angles are the same. And so 12 divided by 3 I know is also 4. So if I have all three of them reduced to be the same, then yes, this is similar. And it's based off of side, side, side.